Yann Simon in French.
Okay.
I'm Scala Developer since quite a long time. I organize Scala Meetups in Berlin.
Oh, cool.
And
nice.
Yeah, I'm interested in a lot of technologies.
Yeah. I'm also quite interested to see, your talk, because I'm not, I'm experiencing GraphQL, but I haven't seen, the process from, the design of the GraphQL schema to taking that schema to production. And I think a lot of people will be interested to hear what you have to say.
Yeah,
so,
we are quite lucky because we had one colleague, Oleg,
okay.
who pushed a lot for GraphQL. He's the creator of the Sandria library. And thanks to him, we had a GraphQL endpoint very early. I think nowadays it's not a surprise to have a GraphQL API, but back in time it was really experimental. So it was very interesting to see the evolution.
True. Very cool. So whenever you feel ready, we can go ahead with your talk. Thank you.
Okay, then let's start. So I hope you can see my slides. I will start. So my talk is about bringing a public GraphQL API from beta to production ready at scale. Before I start, I want to give you a bit of context. What do we do at commercetools? So commercetools is an e-commerce platform, and we are API first. We have a REST API since day one, and we also provide a web application that merchants can use. Our customers also use our API directly, so they use that from their server to run their shop applications. Or they also use our API directly for mobile applications or single-page applications. We are running in the cloud, and we integrate with Cloud Functions and Cloud Queues. So how does GraphQL fit into that picture? So this is our story, how we introduced GraphQL at commercetools from 2015 to 2020. So let's start in 2015. So Facebook published the first draft of the GraphQL specification at that time. And as I said, Oleg, colleague of mine, started working on Scala implementation that became the Sandria library that is used nowadays. And in October, he pushed for the first experimental GraphQL support at commercetools. Between 2015 and 2018, so we continued the experimentation, added more and more types, and there was not so much traffic coming to our GraphQL endpoint. And as you can see, from 2018 until now, the GraphQL, we had more and more GraphQL traffic. And now we are in 2020, and we have a public GraphQL endpoint that is beta, that we want to remove that beta flag. We provide tools for developers, and we are also providing support for our customers so that they can learn about GraphQL and how to use it. So what happened in that 5 years? As you could see, the traffic of our GraphQL endpoint scaled up, and we also had to scale up. So I will look at that from different perspectives, from the operation perspective, how we developed our GraphQL API, and how we scaled up the performances. So let's start how we scaled up the operation. So I will start with an example. We have a look at two GraphQL queries. On the left, the GraphQL queries is asking for products and selecting the fields ID and version. On the right, we're also fetching products, and we also fetch the name of product type for each product. So to fulfill this query, you can see that we have to select products, and for the query on the right, we also have to fetch product type to know the name. You can have the feeling that the query on the right needs more resource to run. And someone could use that or misuse that to send us very complex queries that had to load a lot of data, and that will break our servers down. If you have to load megabyte and megabyte of data in memory, and you do that for several requests, it's very dangerous. So one of the first steps was that we had to protect ourselves against malicious queries. For that, we analyze the complexity of each query based on the schema and how we will resolve each field. And if a query is too complex, then we block that query. So we are sure that it will not be a danger for our servers. If you want more information about how to protect yourself, I added 2 links, one from Apollo and one from Sangria, that document how to do that. Next, when you have a REST API in production, you can have a look at the request response, and in the logs, there's already a lot of information. You know what is going on, if you are creating something, updating, just reading, deleting, if it was an error or not. When we introduce GraphQL, I don't know if you know it, but GraphQL is transport agnostic. You can implement GraphQL on top of Slack messages, email. You can use XML if you want for it. We implemented a quite usual way. We implemented that on top on HTTP. The query is in GET or POST, and the response is in JSON. But when we introduce GraphQL, in our logs, we could almost only see POST requests on GraphQL, and they almost all give 200 back. So we are losing a lot of information, and it's more difficult to know what is going on. To fix that situation, we added more information in the logs. Based on the GraphQL query, we could know, for example, the operation type. Is it a query or a mutation? We could also read the top level fields. I spoke before about the complexity of the query, so we also put that into the log. And we also put how many errors we had when we resolved that query. With those information, now it's much easier to have a look at the HTTP logs and to know what is going on. We also add metrics. So we have general metrics like how many queries, how many errors, where do we spend time, and we have metrics that are more specialized on the slow request. So these metrics provide a global view about what is being slow, so that we know where do we have to look if we want to have better performances. Metrics are not sufficient for slow requests, so we also load very slow queries. And we load them with all the information that we need to be able to understand that query and to reproduce it. Just one thing, if you want to do the same, be careful not to load sensitive data, like user password, for example. So as you can see, we scaled up operation. First, we had to protect ourselves against malicious queries. Then we extended the loads, the metrics, so that we had confidence in operating a GraphQL API at scale. Now let's have a look at how we scaled up the development of the GraphQL API. First of all, we started using it ourselves. I think that's the best thing to do. Our merchant center, demo shop, they are using our GraphQL endpoint. It means internally we have more shorter feedbacks. Developers are talking to developers, giving feedback and suggestion how to improve the API design. We can see that front-end and back-end developers are working together. And we had suggestions how to bring some convention into our API. One of them is, for example, how we can query a field that is translated. Here I have the name that can be translated. We expose it 2 times. Once you can select it for a certain locale, so you have only the translation for that locale. The second field is about having all translations. So here you can see we know the translation for each locale. So these conventions are very practical, but when you have convention, we have to make sure that we are using them everywhere. For that, we added internal validation based on the GraphQL schema. Those validations are automated. And as a developer, for example, if I forget about having this name all locals, then I will have an error message telling me that I missed a field, explain me what to do. We also automated a part of the GraphQL schema. I will explain. Our REST API is following a CQRS architecture. It means we can have different models for the queries and the mutation, exactly as we can see in the GraphQL world. And based on this model that was already existing, we could generate part of the GraphQL schema. That speed up the development, but we also have to make sure that we don't generate too much or that we expose something that we don't want to expose. But thanks to schema introspection, we can test what is exposed. This is one test that we have is we check for one GraphQL type, which fields do we expose? And that test, we can be sure to expose only what we want to do. Automation, we also when we change something in GraphQL, we have a public release notes on our API website, and we could also automate part of these release notes. When we work locally, the GraphQL schema locally is different from the one that is on production, and we have a script that checks the differences between those 2 versions and generate a markdown file that we can use for public release notes. For example, this is a release note that you can find on our website. And from here to that, this is entirely generated automatically. And automated generation also helps having consistent release notes. As you know, we started in 2015, and we made some decision that we wanted to change at some point. For that, we used schema deprecations. So GraphQL allows us to deprecate some fields. So for example, here we deprecated this field, discount rel, and we in the deprecations, we also document what to use instead. So we have to use this field. We also have metrics about deprecation so that we know which deprecated fields is being used and who is using these fields. That way, we can contact customers and tell them, look, you are using this deprecated field, please change your query. And by using metrics, we can also check if one deprecated field is not being used since a long time, and then we can simply remove it because we are sure that nobody is using it. So this is how we scaled up our API development. First, by having faster feedback loops internally to have a better GraphQL API, better design. Then we automated a lot of things to have faster development. Automated generation of the GraphQL types, automating schema validations, release notes. And we could use deprecations to evolve. Thanks to that, now our GraphQL coverage is almost complete. Let's have a look at how we scaled up performances. In GraphQL, it's possible for someone to come up with a query that is very expensive to run. So the first thing is we gave tools for external developers to recognize that. The query complexity that we use to protect us, we expose it as an HTTP header. External developers can use this value and can optimize their query based on that. We are also providing a profiling function that you can profile your GraphQL query, and you can know where is the part where it is not performant enough. As you might know, with GraphQL, the client can only select the fields that are interesting. That is, the server will only set the fields that the client wants, and the payload is quite minimal. And this has an impact on performances. We made an experiment with an Apple Watch. On the left, the application is using the REST API, and the payload is quite big. On the right, the app is using GraphQL and is only selecting a few fields. And now you can see the differences in performances. So as you can see, by having a minimal payload, the application is much more performant. Having smaller payloads helps those devices that do not have a lot of CPU powers, but it also helps servers. A lot of our customers are using server-to-server communication. And if the payload is more minimal, then their servers have also much less work to do. And we have feedback from some customers where they could see much bigger improvement when they start handling minimal payloads. So by using GraphQL, we will optimize the part between the client and the server. But we will also optimize the parts between the server and database. Because the server knows which field the client wants, the server can also optimize the query that is sent to the database. I made an experiment about it and talked about it at the GraphQL Meetup in Berlin some time ago. And I just want to show you the results. So here we are using the REST API, and we are handling a quite big payload. Just by using GraphQL, so optimizing the part between the client and the server, we can see that the performances are much better. When the server also optimizes the query to the database, we can see that we also have much better performances. So this is very interesting. By using GraphQL, we will optimize the whole flow from the client to the database. So we have GraphQL servers on production with quite heavy traffic. And to optimize performances, we also inspect them. So we have metrics that you saw before. We are also inspecting with Flames graph, for example, to know where do we spend time. Based on this, we can come up with some benchmarks. And based on this benchmark, we can optimize some part of our application or some part of the libraries that we are using, giving back to the community. So this is how we are scaling up performances. First, we give tools to external users that they can themselves optimize their queries. We use all the information that we can have from GraphQL queries to also optimize what we are asking from database. We inspect our live servers. And this performance optimization process is a continuous process. We optimize something when you have to look at the new version on production, find out what we can improve even more. So in that 5 years, our GraphQL API evolved from being experimental to now being production ready. And for that, we did a lot investments in a lot of different areas. We invested in automation, automating validation, automating the GraphQL schema, automating documentation. We invested in operation so that we always know what is going on production, and we are able to dig if there's an issue, or we're able to know where we can improve performance. And this is a continuous improvement process. To make our GraphQL API a success, we also had to involve everyone. Of course, as I said, backend developers, front-end developers, also product manager. Our product is API first. Product manager are involved in our API. But also support, sales, marketing to explain GraphQL to customers and to support them when they are using that. So now we're in 2020, and we feel production ready to have even more GraphQL traffic, and we are confident enough to remove our beta flag in the next month. That's all I have, and if you have any question, I will be happy to answer them. Thank you.
Okay, well, thanks, Yann, for that talk. I mean, I took myself some notes of things that I didn't know, and I guess that some of our attendees will have also some other questions. But for me, for example, is probably we can start with one of mine, and I think probably the most that popped up in my head was about the deprecations. And when you want to deprecate a field, like what would you say is the time, from you see that a field can be, replaced by another field, and that time when you are ready to remove it? I mean, how long that process can take, in your experience?
Yeah. So there are different cases. The happy case where no one is using the deprecated fields, and we can see it in the matrix. So in that case, we can simply remove it. In the other cases, it takes quite a long time because we have to communicate to customers, wait for them to acknowledge and to change to change their applications. And only that, after we can see in the matrix that the field is not used anymore, we can remove it. So now we are very, even if a GraphQL is better, we do not break clients. So it means for the moment, we haven't deleted any deprecated fields except one of them.
All right.
And we are in the process of communicating with customers because we want to get out of the beta, and to be off the beta, we want to have a schema with much less deprecated fields.
I see. So that can give you quite a lot of confidence. I mean, knowing that this scenario would be a little bit, worrying for some people, but as you are explaining, I mean, this is quite rare. And in any case, you can follow the evolution of that, that deprecated field, and then find a good time to just replace it. All right.
Yeah.
Well, I'll. There's a question here that I'm gonna just read out loud. So how did you resolve caching, for example, when using Varnish for the post request? If you have any examples on that.
Yeah. So we don't have any, how do I say, generic caching that can cache everything. The only cache that we have, we do that on purpose in the application. So in the application, we have some special caches where we know this data is fetched a lot and doesn't change so much. So we can cache this part of the data. It's an explicit decision from us. We don't have any cache that can cache anything without us knowing about it.
I see. Okay, thanks. I can read the Q&A from Slido. So I'm gonna pick the next one that is from Jonas, and it's let me see if I can get it on the screen so we can read it. So Jonas says, thank you for the talk, Yann. How much GraphQL traffic do you have compared to REST?
I don't have the last numbers, but it's still low compared to the REST traffic. We have a REST API from day one, and our GraphQL endpoint is still in beta. So most of the customers are using REST API first. And then when we explain them the benefits, or if they have developers inside we know GraphQL and would like to use it, then we have traffic from them. But for the moment, the main part of the traffic is still REST API. But we expect that to change, especially when we say we are now production ready and you can go.
Yeah, I mean, this is something that since the release of GraphQL has been, one of the benefits that it has been, sold around the technology. But actually, I didn't see any data like the one that you shown in your slides. So that was quite interesting. And in that regard, would you recommend, in what cases would you not recommend to migrate from REST to GraphQL? I mean, now that you have seen the benefits from the server side perspective and also the client's perspective, it seems like it's a no-brainer. No, have you found any exception to that?
No, for me, it's not a no-brainer. There are different trade-offs. I think first of all, REST API, I would say the simplest version, not the very complex version, but the simplest version is easier to put into place and easier to consume. You don't need any GraphQL client or GraphQL library. Just make a endpoint and send some JSON, and that's about it. Of course, good REST API have much work to do on top of that, but you can start easily with REST. Then I would say on operation point of view, REST embraces HTTP, and it makes some things easier, like routing traffic, analyzing traffic. We have a lot of tools that are based on HTTP. Having only a post on GraphQL endpoints made sometimes things difficult.
I see.
I would say also GraphQL changes a bit where the responsibility are. If you are a client consuming a REST API, you can send different requests to different endpoints. And if one of them is failing, you may think, okay, how can I handle that? Maybe it's crucial data and I will show an error, or it's not a crucial data and I can still present something that is, it doesn't have all information, but that's sufficient. With GraphQL, this responsibility is partially moved to the server. So the server has to say, okay, I fetch data from different endpoints or databases, and if one of them fail, what do I do? And here the GraphQL server we must take a decision, okay, we can still give partial result and have an error, or say it's a complete failure. So the responsibility is moved from client to server here. And then from a client that is consuming GraphQL, they also have to maybe understand, okay, maybe I have a partial response and I have to deal with that. But it's much less explicit than when you send several requests to different endpoints.